Okay, so if you go in and look at, for this particular matrix, which was this matrix here, okay? So starting with this matrix here, because now I could go in and pick this factor, I could pick this factor, I could pick this factor, and it might be pluses and minuses. So if I go through the math on that, okay, this is what happens. I got 7 factors in 3 trials, so there's 35 combinations of that. And then if I go in and take and run it this, there's 280 possible combinations. Okay, that's known. Now, to answer Mike's part is, he's saying, how do I know that I got 90% of those? Well, what we did a Monte Carlo simulation to see what percentage of those I actually covered. So in this case, it's 90%. And we did it also if you had 7 factors, 6 factors, or 5 factors for an 8-trial matrix. They're roughly about the same thing. And that's how I generated a tape for this graph.
Group size of 3, though, for us.
What's that?
The three in your group that you're testing. How do you choose those out?
Those are any 3.
Any 3.
So it's random.
Yeah, well, yeah, because I don't know if it could be factor A, G, or F.
Right.
You know, or it could be A, B, C.
Okay.
Okay, but when you look at all those possible combinations, it turns out to 280 possible combinations. And all I'm saying, by simulation, I determined that 90% coverage is a valid number for that particular situation.
Group size of 3.
Group size of 3. Then if you looked at it here, now if you looked at on 4, there's really 560 combinations on that, and I did 50% coverage. Okay. Now if you go in and look at, for that other experiment they did on the computer one, that's huge. I don't even know what it is. I mean, it's a huge number. But the thing is, you can see I'm still presenting coverage in the same manner.
So are you saying then, if you had the 90% coverage scenario you're talking about there, that you could, and you did all your tests, and you had no failures in any of those tests, that you could tell somebody that you're 90% confident that you won't have a failure?
No, not 90% coverage. No, you can't say that. You can't use the, no, you say I did 90% coverage of combinations of 3 things. And then I'll ask you, I'll tell you this before I begin the test. I'll say, Mike, is that good enough? And you say, no, Forrest, that's not good enough. I say, okay. So then I'll go in and start adding more trials to it. And I say, and then because you want 100% coverage, right? Okay. And then I'll go in and start.
It's a risk thing, right? I mean,
Well, yeah, and it's cost. Because now you get the point, it's cost. Now, like I said, there's other tricks to the trade. Is if you can go in and start breaking it down, like factors A through F are really related to each other, and G through X are related together. You can run 2 matrices and run them at the same time. Okay, but when you analyze them, you're analyzing them separate for coverage, because you know A cannot be a combinational problem with these other ones. So if you,
so that's where the engineering judgment comes in.
Yeah, you know, and the example that I was using is in the old days where you had memory slots and things like that for computers. Those tend to interact and depend on where you're putting in the slots in the machine, things like that. So they were kind of like different beasts, and so you could kind of keep those separate. And so now you can cut down the number of trials and get better coverage for the individual pieces that you're looking at.
Suppose you were selling to a hospital and there were certain things that had to be covered. You have to test because of the critical nature of a failure might be like that situation. How would you incorporate that?
You can go in and, well, for one thing, you could go in and set it up. So you're talking about like for a logic pass fail, or you, because this, you have to keep in mind, this is for a specific situation. It's a logic pass fail.
Yeah, but you treated all of those failures as equivalent, but some of them might be life-threatening. Others might be, okay, my car stopped and I got to blow a little bit.
Yeah, what you can do though is, if you know that these are very few scenarios, that there are very few, well, you can make the design so it makes sure you capture those. So when you're setting it up, you can go in and make sure that those particular combinations are covered in your test. But if you've got a whole bunch of things, then but if say that you got 10 or 20 things, that would be pretty easy, because then you just make sure you're testing.
So would it be additional, or would they replace?
No, I wouldn't say it would be additional. I'm just saying whenever I run this design, I want to make sure that these combinations are covered.
So that would be engineering judgment too, right?
Yeah, well, and that's
for his particular case, it can come out of a FAMICA, failure mode effects criticality analysis. So you go through and with engineers that are doing this design in the design phase, and everybody gets together for this. If these events occur, there's a 90% likelihood outcome of the patient's severity is 5, they're going to die. Versus this outcome is a severity of a 1, it's customer inconvenience. And so, like you said, you go through that, you have all that data up front before you get to this stage. You can force certain levels of the matrix to exist in your test structure.
The situation is really not on individual things. We're going to have them covered. We will pretty much always have them covered. I have never run a time you won't. It's the combinational things that hurt you. Okay, and a lot of times you're not smart enough to figure out what those are.
Well, case in point would be drug interactions, basically, right? So you have different drugs as your factors, and their dosage levels are your levels, if you will. Depending on what that combination is, could either be that it makes you drowsy, or it makes you dead. So you don't know, and that's what you want. What's that?
Extreme.
Right, but my point, and I think to the point that you're maybe trying to get at is the choice of factors that this comes up with is there's no guarantee that it's going to cover the particular set of combinations you're looking for. There's nothing that stops you from testing it outside of this.
No.
To then make sure that you're going to cover it, right?
But the other scenario that you've got, I would venture to say you could do a certain set of combinations for one person, they die, and another person they wouldn't. Is that fair? Is that fair? See, that's not what I'm really trying to do with this. See, now that to me is another type of problem. Is that there you're dealing with, that's more of an interaction. You're saying that it's not a logic pass-fail situation. In other words, you do a certain combination, somebody always dies, or somebody always lives, or somebody gets groggy. Okay, those are attribute situations. Like you might have it 10% of the time if you do a certain combination, it's going to cause death. Okay,
well, no, there could be situations where
a reactor control, nuclear reactor. You're in Japan now. You've got a real nuclear reactor. You say, hey, if this parameter ever fails here, that's meltdown. So we got to figure out. I mean, you almost need to work the thing backwards, right?
Well, see, keep in mind, I got in a pretty good combinational coverage. You're talking about something that's quite simple compared, for its number of factors, I think, relative to what I just did on the computer. So you could go in and run more factors to go in and get a better coverage, or more combinations.
Are you saying, let's say that if you went back to your 7x2 matrix, and you picked one of those states and said, hey, if this one ever fails, that's a disaster. So would you run all possible combinations just to make sure you got full coverage on that particular?
You got 100% coverage on any of the factors by themselves. It's the combination of factors.
I need 100% coverage on all 7 factors.
Well, then you'd have to run all combinations.
You have to do the whole.
Yeah, if you work. No, well, keep in mind though, what you're doing is, that's worse than the problem that Japan had. There was not 7 factors. It was like 3, wasn't it? 3 or 4 maybe. I mean, it wasn't 7, and and so now it's not much different than when I'm talking about 3 things. I think maybe had 4. You had if, this, and that, and so on, and 7 things just don't happen that often. And so now the idea is you get a good